Hey guys, let's talk about correlation coefficient. When you hear this, correlation is going to mean the same thing as we've been calling trend and association. It's just another way to, it's another word that we use for relationship. The correlation coefficient defines the type of relationship between the variables. So it can be positive or negative or have no correlation. So that's the same as saying when we said that a scatter plot had a positive trend, a negative trend, or no trend. Now we're going to use this more technical term, correlation. That correlation can also be strong, which would mean that the data is pretty linear. The scatter plot would look pretty close to a line. It could also be weak, which means it's not very linear. So your scatter plot's going to look like a whole bunch of points just spread out. And there's even a perfect correlation, which means that your scatter plot is exactly linear. So every single point is going to fit perfectly on a line. So for our correlation coefficient, we are going to use this letter R. It's a lowercase r. That's our correlation coefficient. And it can be between -1 and +1. So it's not going to be bigger or smaller. It's got to be between those two numbers. If our correlation coefficient R is positive, then that means we have a positive correlation. So your scatter plot is going to be increasing. If R is negative, that means we have a negative correlation. That means that your scatter plot is going to look like it's decreasing. Every now and then you're going to see this happen where R is exactly equal to 0, and that means that there is absolutely no correlation. Some of the other options, let's see. If R is going to be very close to +1 or very close to -1, that means we have a very strong correlation. So our scatter plot is going to look pretty linear. If it's equal to 1, that means you're going to have a perfectly straight line of points that are increasing. If it's equal to -1, that's going to mean the same thing for decreasing. So it's going to be a perfectly negative line. Then if R is closer to 0, that means we're going to have very weak correlation. So the closer that it is to 0, the weaker it is. And that's when the scatter plot is going to look more scattered. All right, now let's get really into this. To find this on a calculator. Okay, the first thing that you have to do on your calculator is turn on this thing called your stat diagnostics. So on a school calculator here, you are going to want to turn it on. You can clear that off. So to turn on the stat diagnostics, we want to hit the second button and then 0, and that brings up this catalog. And then we are going to scroll all the way down to the D's and find diagnostic on. So that's right here. We want to make sure we hit the on one. I'm going to press enter to select that, and then I have to press enter again for it to say done. That's going to turn on my stat diagnostics. If you have a non-school calculator, I've got this guy here, you can do the same thing and go to the catalog. But for some of us, if you hit the mode button, there is a second page of settings. You can scroll down and there's this stat diagnostics, and you want to make sure that that's on. So 2 different ways to do the same thing. But for the majority of us, this is going to be the way to do it. So second 0 to open up your catalog, and then going all the way down to diagnostics on. You need to be able to do this on your own. On the state test day, I cannot turn this on for you. I can't even tell you that you have to turn it on. So this is a thing that you're going to have to know how to do. So now that we have that on, when I run my linear regression by hitting StatCalc 4, it's going to bring up a few more options in that calculation. So we want to enter our data into the table. I'm going to use this table here, and I'm going to enter that in. So I'm going to hit stat enter. I'm going to clear out my data and put this in. So now that my data is in, my 2 columns are the same length, I can hit stat calc 4, enter, and now you can see I have my y equals ax plus b, my a value, my b value, and now we have these 2 new values. So R, the bottom one, is going to be our correlation coefficient. So you can see it's -0.092, we would estimate that to be. So the fact that it is a negative coefficient means that this is a negative correlation. Then because 0.092 is so close to 0, this has a very weak correlation. We could even go so far as to say because it's so close to 0, this like 0 is after the decimal point, I might go so far as to say that this has no correlation. If we graphed the scatter plot, you would see the points are very, very spread out and they're very far away from the line. Because this number is so close to 0, we would say that a linear regression is not a good model for this data. And just for you to see, I'm going to graph this. Here's the scatter plot. You can see how the points go up and then come back down. They do not form a straight line. They're not even close to making a straight line. So this is definitely not going to represent a linear model. So we would not want to use linear regression for this. If I use this to make predictions about what might happen in the future, my data or my answers are probably not going to be very close to what the true data is. All right, to go back really quick, I just want to make a note. This R squared is called your coefficient of determination, and we will not be using that this year. It tells you how much variation there is between the predictions of the linear regression equation and the actual data. So we don't care about that. You can ignore R squared. We are only ever going to care about R in this class. So that's correlation coefficient.